Hello everyone, today you're going to be learning about 6.1G sums of differences and squares. So what you guys should have is you should have your video up, or excuse me, the notes up, and you're going to take notes on this video just as if I was here. And when you're done, you guys are going to work on a review worksheet, and then after that you guys can go ahead and start your homework, okay? So once you have your notes on, please go ahead and follow along, please. So today what we're going to be doing is looking at the sums and differences of square roots. So it says, Joy explains to Laura that the expression 3x plus 2y simplifies to 5xy. Is Joy correct? Explain or why or why not. And she currently is not correct because we need to follow orders of operations. So when we have 3 times a number plus 2 times a number, you need to add those two numbers first before you could just multiply them out. So what I'm showing you guys here is you cannot add the coefficients. So you cannot add the coefficients of numbers with different variables. So the variables and the exponents need to be the same when we add them. So let's go ahead and look at this. It says, Laura explains to Joy that the expression 4 radical 5 plus 3 radical 5 simplifies to 7 radical 10. Is Laura correct? Laura is incorrect here. Now we're going to go ahead and look at this first rule. The rule kind of treats this like, let's say these were variables, such as 4x plus 3x. To solve these, all we would do is we would add the coefficients. So I would have 4 plus 3 to get a total of 7x. Now I want you to know that when Laura did this, she did the correct thing by adding these two. So 4 plus 3 was 7. But whenever you have an irrational number plus an irrational number, it's not going to add the square roots of the part. So you're not going to have radical 10. You're just going to have radical 5 left over here. So it's kind of like a variable. So it's like you add the coefficients. Oops, I have an x right there. I should not. You add the coefficients, but you leave the square roots the same when you are adding and subtracting them. Okay? So it says we treat radicals very similar to variables or fractions. So what do I mean by that? So if I have something like 7 radical 5 plus 2 radical 5, that would be the same as having something like 2x plus 7x. Or it would be very similar to having it as a fraction with like the same denominator, such as like, what's it called? If we have like 2/3 plus 4/3. When we look at all these, here it's the same process. We add the coefficients, so that would be 9, and then we leave the radical 5 the same, radical 5. So kind of think about it as if it was a variable. If we had 2 plus 7x, 2x plus 7x, that would just give me 9 with the x staying the same. Okay, and here just kind of be like 6/3, and I'm just showing the fractions just so you know it's you keeping the denominators the same. You don't add those up. But more so focus on these two examples, all right? So now let me go ahead and look at this one. Let's start with this part. First thing what I want to do is when I add or subtract square roots, I need to make sure, is the square root the same on both of them? In this instance, it is, so all I'm going to do now is I'm going to add the numbers in front, so 2 plus 4 is 6, and the radical 2 stays the same. Remember, it's the last time I'm going to show you this. If it's 2x plus 4x, all you do is add the coefficients to get 6x. Variable stays the same. Very similar with square roots when we were adding and subtracting. So looking at this one now, same idea. First off, we just need to understand how to read this. This is 5 square root 6 plus square root 6 minus 2 square root 6. Now, there's an invisible 1 right here, and that'll help you when we add them and subtract them. So I have 5 plus 1, which is 6, and I have the square root of 6, and then I still have this minus 2 radical 6. Then what I do is I go ahead, I'm going to subtract these, but remember I'm only going to subtract the coefficients. So 6 minus 2 is 4, and the radical 6 just stays there. I don't need to change anything else. Alright, now we're going to look at ones that look a little bit more tricky. So right off the bat, you would see these ones and you'd be like, hey, I can't add these, because remember, you can only add them when they are exactly the same, when I have the same square root. I have a square root 2 here and I have a square root 8 here. It's kind of like have something like x plus y. Could you add x plus y? No, you cannot. It's as simplified as it comes. But now what you need to do is see, can I simplify any of these before I combine them? Well, I have radical 2. I cannot combine that, so that is just square root of 2. Then I look at the square root of 8. Well, if I look at the square root of 8, I know this is 4 and 2, and 4 is 2 and 2. I have a pair, so I'm going to bring out a 2, and then I have this radical 2 left over. Now looking at this, guys, everything I solved just so we can make sure this is all this part right here. And over here, this is all this part right here. So now what I'm going to do is I'm going to add these, and remember I can only add and subtract when I have the same square root. When I look at these, I do. So I have 1 square root 2 plus 2 square root 2, which would give me 3 square root 2. And that would be my final answer. Alright, same idea now, guys. I have this 135 minus 2 radical 3. And, radical 135 minus 2 radical 3. And some might say, hey, I can't add or subtract these at the moment. Well, that might be true, but let's go ahead and break it down to make sure. So if I were to divide these both, let's see, 135, that's divisible by 5. And 5 times 26, 27. 27 is what breaks that down. So then what we're going to do is see, can anything else be broken down? So this would be then 9 and 3. And one more time, I'm going to see if I can break it down any more. And that would be the 3 and 3. I'm now looking for pairs. I have a pair of 3. So I have 3 square root and everything left over, which is the 3 times 5 minus 2 radical 3. I then combine everything on the inside, which is 3 radical 15 minus 2 square root 3. When you look at these, then you can see, hey, look, the square roots are not the same, so therefore you are done. This right here is your final answer. It's similar to having an answer that might look like 2x minus 4y, something like that. Okay. So if you have any questions there, please let me know or your neighbor know. All right, now we got a bunch of things right here, and some of these we're going to be able to combine, some of them we are not. So first off, I need to see, can I simplify any of these? First thing, I have the square root of 2. That is completely simplified, so I'm just going to leave this as 7 square root 2. Minus, now the next part, I have square root of 18. Square root of 18, that breaks down to 9 and 2, and a 3 and 3, and I have a pair of 3's. So now I have 3 square root 2. All right, perfect. And now what we're going to do is move on to the next part. I'm just going to write 7 square root 2 right here. So then the next part, what we're going to do is see if we can simplify 3 radical 8. Now this part is a little different than we've seen previously. So this is 3 times the square root of 8. And we know the square root of 8 can break down to 2 times 2 times 2. And I have a pair, so that's going to come on the outside. So it'd be 3 times 2. This 2 is what I just brought out from the square root. And I'm going to have the leftover square root 2. So then I multiply everything on the outside. That would give me 6 square root 2. Now that I have all the same square roots, radical 2, radical 2, radical 2, I'm going to leave a radical 2, and then I'm just going to add and subtract my coefficients, which is 7 minus 3 plus 6. 7 minus 3 is 4, plus 6 is 10. So that would give me 10 square root 2. Questions there? I don't know if you have questions because I'm not there. Ha ha ha. Okay, so let's go and look at this one now. We're going to break a lot of these down. So I actually want you to try this one on your own. And if you, I want you to try this one on your own. And then I want you to go back and watch the video to see if you did it right. Okay? All right, guys. So at this point, you should have solved it by now. So I'm going to start by breaking this up. This is 6 times the square root of 3 times 3 times 5. And this I would have a pair right here. So this would simplify to 18. Let me take a step back. So I'd pull out a 3, which would be 6 times 3 square root 5, which would simplify to 18 radical 5. All right, now I'm going to subtract whatever the square root of 320 is. So I'm going to go ahead and break this down into 32 and 10, and then this would be 8 and 4, and then 8 would be 2 times 2 times 2, and this would be 2 times 2. And then I have 10, which is 5 and 2. So I have a bunch of 2's here. I have 1 pair, 2 pairs, 3 pairs. So that means I'm taking out 2 times 2 times 2, the radical 5 right there. And 2 times 2 times 2 is 8, radical 5. All right, the last one, let's go ahead and break this down. I'm going to have 2 times the square root of 5 times 3 times, so that was 15 and 10. 10 is 5 and 2. Okay, so now what I'm going to do is see if I have anything that I can take out. I do. I have a 5. Let me make sure I got 150 right. 15 and 10, 5 and 3, 5 and 2. Okay, just wanted to make sure I got that right. So that means I have this 2 already outside the square root times the 5 I'm bringing out, and then I have the 3 times 2 left inside the square root. Remember, you multiply what's outside with outside, which is 10, and you multiply inside with inside, which is 6. All right, here, now guys, I can only add and subtract things that have the same square root. So when I look at these, the only things that have the same one is radical 5 and radical 5. 18 minus 8 is 10, and I keep the radical 5, plus I'm going to have 10 with the radical 6 left over. All right, cool. So let's go ahead now and look at the next one. Next one is explain in words how to apply the distributive property to simplify this. All right, so whenever we distribute, we can only multiply things inside a radical with inside a radical, and numbers outside the radical with numbers outside the radical. So let's look at this. Another way to think about this, guys, is if we thought what the square root of 1 is, it's just 1. So what this is saying is 5, and this part's invisible, square root of 1 plus the square root of 8. And what we can do is we can take this radical 2, and I can distribute it to each square root. So essentially what I'm going to have is 5 times the square root of 2 plus the square root of 8 times 2. This 2 got distributed inside to the radical 1 and inside to the radical 8. So I want you to notice nothing got multiplied to the outside to the coefficients, because you multiply square roots with square roots and whole numbers with whole numbers. So then I can't do anything here, so this is just 5 radical 2 plus the square root of 16, and the square root of 16 is just 4. So I'm going to have 5 radical 2 plus 4. Now, really importantly, guys, this is your final answer. There's nothing more for us to combine. I cannot combine the square root of 2 with the positive, or 5 square root 2 with positive 4. This does not equal 9 rad 2. That is wrong, because you can only add them if the square roots are the same. So yeah. So, explain the expression radical x plus radical 2, all in parentheses, the second pair. Does that equal the square root, does that equal x plus 2? So let's go ahead and look at this. This one does not, because we need to follow the order of operations. So let me show you this one. This is saying radical x plus radical 2 square root. Since this whole thing's in parentheses, but the square root does not cover the whole thing, you'd have to take the square root of the inside of x, then of 2, then add those numbers together before you square them. So what it's trying to make you think this is the square root of x plus 2. Here, guys, what you would do is you could say, hey, these cancel to give you x plus 2. That is not the same what it shows over here. All right, so let's go ahead and simplify this one. So, first thing what we can do is we can either focus on what's inside the square roots first and see if I can simplify or combine them, or what I'm going to do first is actually distribute this to everything on the inside of the parentheses. So really quickly, guys, this would give me, my first parenthesis would give me the square root of 6 times the square root of 3, so I can put those under one bracket. And then minus the second part, I have a second square root of 12 minus the square root of 3. That also goes in the same bracket, same square root, I should say. So then when I break these down, I'm going to have 6 breaks down to 2 times 3. Then I already have this times 3 right here. Minus 12 breaks down into 2 times 2 times 3. And then I already have this times 3 right here. All right. So now I'm going to see if I have a pair. I do. So I have this 3 radical 2. And then over here I'm going to see if I have a pair. And I actually have 2 pairs. I have a 2, which I'm going to bring out, and I have a 3, which I'm going to bring out. So then I would be left with 3 radical 2 minus 6. Here, this is your final answer. There's nothing more we can combine, and so then we're done. All right, next one. So this one gets a little bit more trickier. Remember, we can add whole numbers with whole numbers, or I should say integers with integers, and we can only add numbers with square roots and subtract numbers with square roots when they have exactly the same square root. So let's go ahead and look at this. First off, I have 3 plus square root of 2 times the square root of 20 plus 4 plus the square root of 45. I want you to realize this is all plus stuff. So I can use commutative property to just write 3 plus 4. Now let's focus on the trickier part, which is the square roots. So I'm going to start right here with the square root of 2 radical 20. Let me take that a step back. We're going to start with 2 times the square root of 20. So 20 breaks down into 4 times 5, and 4 breaks down into 2 times 2. I have a pair. So I already have this 2 out in front, and now I'm going to bring out this 2 out in the front here. And I'm going to be left right my leftovers, which is this 5 right here. So this will give me then 4 radical 5. So I multiply numbers on the outside, numbers on the outside. Next thing, let's go ahead, I'll move to the next question, or on the next part of the question. I'm going to look at the square root of 45. I'm going to solve that in purple. So the square root of 45 is 9 times 5, which is equivalent to 3 times 3 times 5. I have a pair, so this 3 is going to come out on the outside, and I have a square root of 5. So if I write everything that I had down, I had 3 plus 4 rad 5 plus 3 rad 5. Remember, I can add integers with integers. So I'm going to do 3 plus 4, and that's going to give me 7. And now the second rule is what we looked at a little earlier. I can add the coefficients of numbers with square roots that have exactly the same square root number. So 4 plus 3 is 7. I'm going to leave it as radical 5. I then look at this. I can only add and subtract numbers that have the same square root. This has a 7 square root 5, and this one does not have a square root. Therefore, this is your final answer. All right. Now, guys, what we're going to look at now is something very, 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 very important. So it's going to be called rationalizing the denominator. Now, it never, ever, ever wants you to have a square root in the denominator. Square root of a non-perfect square. It's basically saying you have an irrational number. And picture this. Remember, it's always part over a whole, and your whole is a number that goes on forever. So they don't want that. So this is what we do to do what's called rationalize the denominator. We want this to be a rational number. What you're going to do is whatever square root is on the bottom, we are going to multiply the numerator and the denominator by the same square root. Because look at this. If I were to do this, just the denominator part, we're going to look at square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is just 3. So whatever you multiply the denominator by, it's just going to be that same number without the square root. And now what I want to do is I'm going to distribute the square root of 3. Remember, it's multiplication, so I need to distribute it to both of them. 2 times radical 3 is just 2 radical 3. And then radical 3 times radical 3 is just radical 9, and the square root of 9 is just 3. So I'm going to have 2 radical 3 plus 3. And I got that by doing the square root of 9 is 3. Now, one big mistake students make is they want to simplify these 3's. You have to look at the coefficients of every single number on the numerator and the denominator. If they're all divisible by the same number, that's when you can take the square root. In this instance, since I have a 2 here, which is not divisible by 3, you cannot simplify this anymore, and your final answer is 2 radical 3 plus 3 all over 3. Alright, so now let's go ahead and look at this one. I'm going to distribute this radical 2. I'm going to distribute this radical 7 to the 2 and to the 3 times the square root of 112. So this right here would give me 2 radical 7, and remember I can combine those because it's multiplication, minus 3, and I'm not going to multiply 7 times 112 to get whatever that is, like 784. I'm just going to leave this as 112 times 7. Now the reason I'm doing that is because I'm trying to find pairs to see if I can take anything out. If I multiplied those, I would just end up with a way bigger number, which would make it harder to solve. So I can't simplify 2 square root 7, so I'm just going to leave this as 2 square root 7 minus 3 times, and now I got to break this down. So 112 breaks down to 56 and 2, and 56 and 2 is, if I divided that by 2 now, would give me 28 and 2, and then this would give me 2 and 14, and then 2 and 7. And if you notice, I already have that 7 over here, so it's basically I found that pair. So let me go ahead and lower this so we can combine it over here. All right, and let's see if I have any pairs now. So I have one pair, so I'm going to bring out that 2. And then let's see if I have another pair. I do have another pair. I have another pair of 7s. So I'm going to have a times 7. Now I'm going to have this leftover 2, which I'm just going to write is now the square root of 2. All right, so now let's go ahead and see what I have as my final answer. I have 2 radical 7 minus 3 times 2, which is 6. 6 times 7 is 42. And I have a square root of 2. I then look at those and I say, can I simplify those anymore? And I cannot because they have different square roots. One's the square root of 7, one's the square root of 2. Alright, almost done, guys. So let's go ahead now. We got a handful of these left. I'm going to do a few more with you, and then I want you to do the rest on your own and then double check your work with me, okay? So let's go ahead and look at this. I have 192, 72, and 75. So if I have 192, I'm going to try to look for pairs. So this would, if I would break it down to 2 and 96, and if I broke down 96, that would be 2 and 48. And then this would be 2 and 24, 2 and 12, 2 and 6, 2 and 3. So then when I'm circling pairs, I have 1 pair, 2 pair, and 3 pair. So that would give me then on the outside of this one, I would have then 2 times 2 times 2, 1, 2 for each pair, and my leftover, which is a square root of 3. Okay. Next one, I have 72 and 5. So then I'm going to have the square root of 72. That is 8 and 9. 9 is 3 and 3. And 8 is 4 and 2. And then 2 and 2. Once again, I'm looking for pairs. I have 1 pair. I have 2 pairs. And I have this leftover 2 right here. So then on this one then, is a subtraction sign right here. So I'm going to write minus. And this would then give me a 2 I brought out times a 3 I brought out. But I still have the square root of 2 left over. And next one, I have square root of 75. So I have the square root of 75, and this breaks down to 3 and 25 and 5 and 5. So I have a pair of 5 square root 3. So then I'm going to have plus 5 square root 3. So now looking at these, I'm going to simplify them all down a little bit. So I have 2 times 2 times 2, which is 8, and then the leftover radical 3, minus, and the purple one is 2 times 3, which would be 6 radical 3, plus, and then I have just the 5 radical 3. Now remember, I can only add and subtract numbers that have, I made a quick mistake right here. This would be 6 radical 2. So I can only add and subtract numbers with the same square root. And on this one, I have the square root of 8 radical 3. And on this one, I have 5 radical 3. So I can add those coefficients. So 8 plus 5 is 13 square root 3, Remember, when we add and subtract, the square roots stay the same. And then I just have this left over, minus 6 radical 2. I cannot combine these because they have different square roots. So this is my final answer right here. All right, so on this one, there's a few ways to solve this one. First thing is, big bad thing I have right here is the square root of 2 on the bottom. Now, instead of rationalizing it right away by multiplying the numerator and denominator by radical 2, which we will do, I want to see, is there anything I can simplify on this one first? So the square root of 4, yeah, we can do that. The square root of 4 is just 2, minus 2 times the square root of 9, and the square root of 9 is just 3. And that would give me then 2 minus 6 all over radical 2, which is negative 4 square root 2. Now, basically, guys, remember, this is saying I have part over whole. I have a negative 4 over a number that goes on forever. And we don't like it when it's written like that because we want the whole part to be a rational number. So to do that, we're going to multiply the numerator and the denominator by the square root of 2. And square root of 2 times the square root of 2 is just 2. And if you want to see why, this would give me radical 4, and the square root of 4 is 2. And then here, guys, remember, you can multiply outside with the outside and inside the square root with inside the square root. So this would give me negative 4 times the square root of 2. Now I look at the numbers in front. If I gave you negative 4 over 2, could I square root that? And yes,